3, 2, 1, go. We're live. This is Retraice segment number 87 for Monday, December 19th at 2022 at 10 p.m. Eastern, 7 p.m. Pacific. Retraice is about what's going on out there. The short answer to that is computer control. The long answer to that is natural, artificial, and strategic intelligence and humanity, which is the best part. And Retraice is for outsiders, but we came to the conclusion that outsiders are not players and the computer control game is player-oriented. So we're learning to play. See, I'm getting there. I only stumble a little bit now and then, every time, now and then. We're in the Math and Code December to Remember Math and Code event in preparation for our study, our deep dive first 6 months of 2023 study of AIMA4e, Artificial Intelligence Modern Approach. December to remember. I will remember this December. Mathematical disclaimer, code disclaimer, engineering disclaimer. I should not be here, any of those things. Whatever you need. We're just hanging out. It's just a podcast, man. Chillax. Amendments and corrections. No content that I caught yesterday, any content mistakes, but I did for like a minute or two. I was on the wrong screen, so I thought you were looking at my terminal and you were looking at a map, something like that. My bad. All right. What are we doing? We are working on best first search. We're trying to, again, we're not focused on the AI code. We're not trying to learn AI here right now, even though a lot of incidental AI learning is happening. We're trying to just get our chops with the programming. That means understanding and being comfortable with Python, but it also means being comfortable with just programs that have a complex structure or a complicated structure to more generally. It doesn't matter what programming language you're in. If you've got to jump around to different functions and classes and and the methods and attributes of objects, and you gotta have methods for this, and you gotta have we're just getting comfortable. We need to be comfortable. Let's get comfortable. All right, let's review. We're trying to get from A to B, Arad to Bucharesti in Romania. We don't want to use our brains. We want to make a computer do it. So this is the state space, all the states that we could be in our journey from A to B. This is my mouse is not working. This is the search tree that we're going to, and what's the word they use? They use the perfect word, superimpose. I was going to say impose, superimpose on our state space. So the search tree is the maroon part, the purple is the state space. The code we're working from is on the official AIMA GitHub page, AIMA Python in particular. We're not doing the Java implementation, we're doing the Python implementation. You can see the code that we're going to be doing today or looking at today in Re87 on our GitHub page, Retraice GitHub page. And we've done a few things already that you should review, okay? So more generally, we're trying to go from the idea that we need to get from A to B and we want to use a computer to do it, to actually doing it with a computer, which involves turning things into code. And we're going to do that piece by piece until we get there. What you're looking at now is some source code. I've sort of folded out the parts that I don't think we need to see today, and even more cooler, how do I do this? No comment. There we go. Even the comments are out now, so we're just looking at the code because I know the screen is already cluttered and we need to minimize the clutter here. So we are going to depend on an import today. This default dictionary. I don't know what it is, an object or a class of object, I don't know. And our basic problem class is called problem, and it takes the class object. Its subclass is the class object. I don't really know anything about the class object. It's initialization. It takes the initial state, your goal state, and then keyword arguments if you want. It doesn't have the actions and results methods implemented, and it has only a very basic cost function implemented. So that's the parent class for problem. Route problem is the one that's more germane or pertinent to our particular kind of problem. It's a route finding problem, and so they've implemented a subclass of problem that has more specific implementations of actions, result, and action cost. And we're working on actions right now. This is sort of the point at which our understanding breaks down, or broke down yesterday anyway. So you've got the actions method on a route problem takes the state that you're in and returns the neighbors of that state or the other location. So what that means in practice is if you're in state A, you should you've implemented your problem in the form of a route problem class. So it's an object instantiation of the route problem class. If you call your problem with the method actions and give it the argument of A, which is your state, you should get back Z, S, and T. Just the first letters of these three places you can go. Those are your neighbors. Those are your actions in our formulation of the problem. Our actions are the places that we can go to from where we are in this particular search problem. Okay? So that's what we're looking at there, that particular method. What does that look like? Oh, did I, let's see. No, I'm not even there. So it would look something like this. If the object that you've instantiated of the class, or the instantiation of the class, your object is called A to B problem, which is an instantiation of the route problem class, and then you type dot map and dot neighbors. No. That's how you would do it if you didn't use the action method. It's up here that this is how we would do it if we were just using the method. So you type A to B problem dot actions, and then in parentheses you'd put S1 as your state, or A, or whatever your state is in there. And I might put that S1 in quotes. I don't know. We haven't really done this yet. That's why we were working through it so we can understand what it is before we try and run some of this code, because otherwise we're just going to be wasting time running experiments. Okay, the real point of interest here is this neighbors thing, and really the map thing. So we started to talk about it yesterday. So let's talk some more. Sorry, I'm jumping around here. One more. There we go. Okay. So we have a class of map. We have a class called map that's going to define our objects, our map objects. And a map looks like this here. They've implemented one for Romania. This has the links are the actions. So to go from O to Z is an action, and it comes with a cost of 71, or the distance. Goes. I don't know if that 71 is going to be the cost. It should be the cost, but I don't know exactly if we're going to have to do one more step or whatever to make that into the cost. But that's definitely the miles on the map correspondence there. And then down here, the other dictionary, which is the second argument that we would pass when we're instantiating the class map, is the don't do that. I did it so well, and then I didn't. I'm still figuring out the best way to jump around. So this is the first dictionary here that we pass as an argument, and you can see, like, where is it? Did I fold it? No, because it's up here. Map. Where are you, map? There we go. So when you're instantiating a map, you get this, right? This is your syntax. You pass two arguments. One is links and one is locations, and that really is, in our parlance, in our nomenclature, links are actions in AIMA4e on page 71, and then locations are the state space in our problem formulation. And just to bring that back a little bit closer to earth, one of the first things we distinguished was the different aspects of formalizing, or the different elements necessary to formalize a search problem. And you need a state space, the set of all possible states. So that is, whoops, nope, we're not doing that. There we go, state space right there. Okay, that's the second dictionary we would pass when instantiating a map. And then the actions, okay, so an action takes an argument of state and returns a finite set of actions that can be executed at state. So let's say we're at state arad, and we pass that to the actions method on our problem, and it should return a finite set of ZST, because those are the actions that we can take, or those are the things that represent the actions that we can take, which is just going to the next city. That's the only action you can take. You can't do anything else, not in our formulation of the problem. Okay, so that lands our plane more or less at this maps neighbors situation. Map.nab, No. Okay, there. That's not it. Is that it? No, it's up here. Okay. So we're in route problem, the class route problem, and we want to understand what if we call actions, if we do something like this, okay, if we do something like this, and really, I should not do it this way. Let's just keep it consistent. Okay. If we pass an argument to the actions method on A to B problem, if that's if we call our problem A to B problem, we're going to get back. We should get back those 3 letters. We should get back the 3 letters Z, S, and T. Okay. But how? Like, I mean, we know it should happen, but how? How does that happen? Okay, let's just get this stuff out of the way because it's just clutter right now. What else is clutter? Anything? This is not clutter. Okay, so the other thing that we have to pass to route problem is a map. Okay, up here that's the 3rd argument. It's a keyword argument, and it's because you need to be more specific when you're defining your problem. You have A as your initial state, B as your goal state, and then what's the state space? I mean, we can't just think we want to change A to B, but they're what are A and B? They're elements in a state space. Tell us more about the state space. That's what the map is. Here I've called it simple map. Is that the best name? I don't know if I'm being consistent. It will be consistent in the end, but I don't know if it is yet. Well, what's a simple map? Well, it's going to be an instantiation of the class map. The example that they give is the Romania map, okay? That's an instantiation of the class map, this object, and it's got actions and it's got states, a state space, and it's got actions. Those are the 2 things that define a state space. I shouldn't call this a state space. Because a state space, I think, includes the actions, okay? So we'll do that and be more kosher and good to ourselves. Okay, so we are passing initial and goal states as well as a state space to a route problem when we instantiate it. Let's see, where's their problem? Is it here? Oh, no, it's down here. Okay, so this is them. Finally, after they've defined maps, or a map of Romania, a state space. The map is the state space because it has actions and states. Then they give R0, R1, 2, 3, 4. These are their particular problem objects. Get from A to A in the map of Romania, get from A to B in the map of Romania, get from N to L, get from E to T, that sort of thing, okay? And we're not there yet because there's a lot that has to happen to actually solve that problem that we don't yet understand. And we're focused today, I guess, on the multimap function because we did talk a bit about the map class, but this multimap function is a function. It's a standalone function. It's not a method on the map class, although that's where it's being used. But really I don't know why they call it multimap. What it really is that it's neighbor finder. Okay, multimap maybe should be thought of as neighbor finder. So first things first, it takes an argument of pairs. We'll come back to that. This arrow and the word dict, okay, this is, it's called a function annotation. This is sort of like fancy comments. It doesn't, I think you can use it for like testing and checking your code, but it's not necessary to execute the code per se. And I give a source on that. So given key value pairs, make a dictionary of this. I think this is that their comment? Oh, geez, let's go have a look here. Let's go see what's what and who's who. Do that. And, oh, it's right there. Okay, yeah. So given key value pairs, make a dictionary of the key value, of the form key value as a proper dictionary. So given these tuples, given tuple pairs, because the parentheses are tuples, square brackets would be a list. So given tuples, tuple pairs, doubles, turn it into a dictionary so that we can use the key to look up the value. Okay, so that's what we're being told to do there in the comments. And this is the, so this is a suite. I looked into suite versus, the terminology is, my vocabulary of Python structures is not good enough to continue with that paragraph. Let's stop that paragraph. Okay, set the word result equal to the default dictionary taking an argument of list. Okay, from collections import default dict above. Okay, so what way at the top here, one of the imports that they do at the top of their IPy notebook is this import, and that has the default dict. So that's coming from collections. Okay, so yes, there. So that's what that is. So we don't have to wonder about that. List is, it's making a list out of the default dict. I don't know. It's like, I'm gonna have to run some experiments on this. Okay. Well, see, I should say that's that's the real way that I've been proceeding when I don't understand things, and really seems like a good general method. Let's do this. Are we in? Yes, we are. Kill, yank, and actually kill and yank. Okay. Now I'm just going to use this as my little experimentation space. No, I can't do that because I have, no, I don't want to go that far. Oh, no. Okay, everything's going crazy. Everybody relax. Because I have to do it below these things. And I don't want to hide this stuff. Oh my gosh. Okay, let's do it right down here. So I want to know what list means. What's our pairs? I don't even know. Default. So given key value pairs, make a dictionary, and multimap is used up here. It's taking links. Okay, so the first argument that we give when we define a map is the links. And that's this. Here it's this, but this is kind of complicated. So let's do something more simple. Let's work with a map called tmap. Okay, and it takes tlinks and tlocations. Okay, so let's first just make sure I didn't fat finger something and this isn't gonna run. Okay, that's good. It doesn't look good, but it is good. I swear. It's just this little thing. That's what we're seeing there. Okay, one more time. There we go. Okay, so this file is, what is it? Control H? No. Meta H? No. Control X H. There we go. This whole file that I'm working with, best first search re87.py, is my input, and map.neighbor. Oh no, I'm good. Oh, I folded it up nice and good. Okay, working on my presentation skills here. My input is this big file, and then my output is down here. So I'm just basically using Python, calling Python and giving it the argument of the file that I'm editing in the top window in Emacs, and down here I'm just in a terminal in a Zeesh. My shell is Zeesh, and my window manager, environment manager is tmux. Okay, so when I do that, I'm running the whole file. That's why it takes a little bit of time, because it's like doing imports every time. But this seems like the easiest way to sort of do what I need to do for presentation purposes right now. Okay, so when we define a route problem, we give when we initialize a map, when we instantiate a map, we give it the links, the locations, and the locations are none by default, and then if it's directed or not, but it's directed as false, and we don't deal with directed yet, so we're going to ignore all that. Actually, if not directed, so I can't fold that. Okay, so the map, see, it's like I jump back and forth. Like I want to understand just how to get the neighbors, but then you got to understand multimap. Then to understand multimap, you need to understand links, and then which is pairs down here. When you look at the definition of multimap, and then you jump back up to the class map, because what's links, and so there's a lot of jumping around. All right, let's just take a second here. I'm not sure what's going to happen to my brain between now and when this becomes easy to hold in my mind. And I'm using the words brain and mind synonymously. If you really look at like what you have to hold in mind in order to understand, I mean, what any part of this, first of all, the whole time you need to be thinking from the bottom up or the top down, whatever you like, about that state space, and then imagining superimposing a search tree over it. And then you also need to start thinking in terms, that's the search tree, you also need to start thinking in terms of the formalization of that problem. Like when you look at the map, you think get from A to B, you can't use white space, you can't go off the reservation. And then and all the other rules, like you need all the different places you can be, place you start, place you want to end up, things you can do at any given state, what happens when you do one of those things on your state. So like the actions, like I can see, this is strange to me. The transition model takes the state and returns takes the state in the action and returns the state as prime. In our particular map, which is our state space, the actions specify the next state. You know what I'm talking about? Like if we go down to this, these are our actions, right? You got initial state and then action. I don't know. I mean, I guess this whole thing is considered the action. And then the state that results from it is just the Z by itself. And then that's, oh, yeah. Okay, so this action that I got highlighted will result in this state, this one down here, okay? So that's how we need to think about that. This is the S prime. This is state prime. This is Z with the coordinates of 92, 539. Anyway, we need to be thinking that way when we try to understand the multimap function, which is used by the map class. Multimap takes links, so our links are our actions. So the multimap takes actions and it returns neighbors. Well, it doesn't return it sets an attribute neighbors equal to the multimap function applied to the argument links. And then, so what does the multimap function output? It outputs a dictionary, okay? And it says given key value tuples. And so like if we pass it on line 119, we're passing it links. Our links are these pairs, these key value pairs. No, not key value pairs. It's just these tuples, the OZ tuple here in parentheses, not the 71 included with it. We're going to pass it those pairs, and I got to fold this stuff. This is not helping me. Let's just get this stuff out of the way for now. There we go. All right. We're going to pass the pairs. And how? It's saying that we pass links. And the links that we're sending to our map when we define, or when we instantiate the class map as the object, what is our map called? Our map is called, I just folded the damn thing. Well, let's say it's Romania, okay? We're passing, like you see at the bottom of the screen there, line 169, the O, comma, Z, and then colon 71. The OZ is a tuple in parentheses there. And then that colon 71, that's a key value pair. It's in a dictionary. The braces at the beginning and end of that big argument indicate to us that it's a Python dictionary. We're passing a Python dictionary to our map class. And within that class, there's as it initializes and sets and does a couple of things to set, okay, so links, no, look, links gets messed with a little bit. Yes. Yeah, I remember this now. I went through this today, and I'm still not there yet, as you can hear, but as you can see by this comment, if, okay, so we pass the actions, which are called links here, to when we instantiate Romania, we pass the links there, which are key value pairs, a dictionary. If links doesn't have attribute items, then set make link, it's basically rebuild the links dictionary thusly. Link :1 for link in links. And I think this means that if and actually I think I tested this, if our links, so let's do this, okay? Let's define, so first of all, tlinks is just our simple, why did I call it T again? Oh, test links. Yeah, I was like, what the hell did I? Okay, test links. So let's do this. Let's do, actually I already did it. I want to know if tlinks has dictionary, distances. Is the thing I'm trying to explain is the items thing. This items thing is what is not obvious. Okay, what is it? Uncomment. There we go. Let's run this. So what we're doing here is we're printing the question, does tlinks dictionary have items? And so then on line 153, I use the print function to use the has attribute true or false function on the tlinks, asking basically, does the tlinks object have items? And it says true, and you can, let's see if it does that. It's false now. Okay, so it has items. That's crucial. Like what we're doing here is we're sort of probing this code and the objects that this code implements and interacts with, because you can't always get an explanation from someone or somewhere. You really have to kind of examine the code and the behavior of the code itself. So we have to do that. How do we examine? Well, I think the best way to examine objects in Python is the dir built-in function and the dict method, magic method. Okay, so let's ignore this. And okay, so let's, whoops, actually I already did this too. What are we doing? We're working on tlinks, print tlinks. Okay, so the tlinks is probably not going to have any methods. Print tlinks, and then it's cool because I can, if I start it, whoops, if you start a magic method, I'm using LP. I think LP is the Emacs package. You call it a package, the Emacs plugin or add-on that's going to show me this list of methods that are available on tlinks, and I'm pretty sure that's what this list is. I don't think it's just a generic list. So I define tlinks up there as a dictionary. Let's just see what its class is. Yeah, class dictionary. Okay, that's what's going on there. So now let's do, because tlinks is, we know it's a dictionary. It's not, it's not going to have what? What methods does it have? Let's see what methods. Annotations. What is annotations? I don't know. Let's do it. Yeah. No attribute annotations. Okay, so that says to me that LP is not as clever as I thought. Because, I can get class, but does it have a dict? It is a dict. Let's see what comes back here. Yeah, it doesn't have these attributes because it's not that it's not an object. It's just a dictionary type of object, which doesn't have, let's see what it does have. Okay, so we're going to put it in, actually we should leave some of these up for the post-game report. Okay, let's leave that one. And Gotta get quicker at this. Comment line. Okay. Yank. And now we are going to use the, going to use the dir built-in function. Okay. Do that. Now look at all these. So first, I'm going to mute these other things. It's just confusing. Okay. Oops. Let's do this again. Do it again. Clear the screen. One more time. These are a bunch of magic methods. Class get item, blah, 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 blah. Everything with the double underscore. The dunder methods. But then we've got things like over here. Clear. Clear. Copy from monkeys. I don't know, from keys. It looks like from monkeys. Let's do from monkeys. Get, and then look, items. Look. This is the one that sort of confirms to us that the items thing are here. Okay, so when we're instantiating a map, and the first thing that the class does is it manipulates our links argument if it does not have attribute items. So we're passing it the links, and our links do have. Okay, so do our links have items? I have to convince you that our links don't have items. So look at this. Okay, I created here tlinks no distances. Okay, so it's just a basic. This is my very simple tlinks test links, right? So you got A to Z, A to S, A to T. Why? It shouldn't be gobbledygook. Okay, it's right from our beginning state. We're at A. This is our state. A to T, A to S, A to Z. Okay. A to Z, A to S, A to T. And it's got the distances as well. Okay. 118, 140, and 75. Right here. 118, 140, 175. And then we see, right there, 118, 140, and 175. No, and just 75. Okay. So that was just copied from Romania down here. Okay. But we want to do one without the 75, the 140, and the 118. Why? Because we want to confirm to ourselves that the links thing that's going on here, this has attribute, has at, this thing is really checking something that we understand. Sorry, I said links. It's checking items. Okay, the items. Does this work? I guess the way to think of it is the question we're asking is, does this items here, when we're asking, does the links object have the attribute items? Does that correspond to our distances of 75, 140, and 18? Okay, so let's create a dictionary just like our tlinks dictionary, but without the 75, the 140, and the 118. Okay, now let's go down here. I don't know why we're doing this stuff down here, but we're doing it that way. Actually, just do a little bit more housekeeping. There we go. And why not? Okay, so now comment line and do that, and now let's check our no distances. Okay, so now when I run this code, what I'm going to be doing is printing the dir built-in function applied to our tlinks no distances, and we should see something different. Let's see. Items. Oh, look at that. It's not there. I didn't do that test before. It's really not there. Check. Look. Okay. Look at that list. We're going to reverse search for items. Okay. Well, you can see it further up, but it's not in the output of what we just did. So now, just to be crystal clear about this, okay, we're going to print the dir, I don't know what dir stands. I think it stands for directory. It's kind of an iffy thing. Actually, I will show you how iffy it is. Come on. Uh-oh. That's not good. That makes no one happy. Why? Oh, I'm going to have to manually do that? Darn it, my OBS is failing on me. Okay. If we go to the Python documentation and we go to the dir, the built-in function, it's very iffy. It's like, you know, with an argument, attempt to return a list of valid attributes to that object. First of all, it's saying attributes, but I'm not seeing, oh my gosh, my hotkeys broke down. I'm going to be clicking for the rest of the day. We're going to have to, okay, well, it's all right. We're at 35 minutes anyway. Oh, look at this. That's slick. Yeah, well, my hotkeys are broken. I don't know what broke them. It's not my fault. It is my fault. Everything's my fault. Okay, so up here, you know, or down here, we're looking at, I mean, I don't think of these as mostly attributes. These are all magic methods. And then maybe some methods, I don't see any, what's an, our attribute, well, our tlinks doesn't have attributes. What is it? Okay, doesn't matter. The point is, the dir built-in function is sort of attempting to do things, and it's not clear what it is, so you shouldn't trust it with your life. It's just a way of sort of probing the object. So we're using the dir function on tlinks, our tlinks list, okay? And we're also using it on, and let's just print a little space here. This is a gap. And does new line work there? I don't know. I don't do a lot of printing in Python. Let's just see. It works. Good. Okay. So let's just do this one more time so it's nice and clear. Okay. So this is the output from our first print call of the dir function on tlinks. Okay. And we can see items. Okay. See that in purple? Items. Okay. That, I argue to you, dear listener, oh geez, is there because of this 75, this 140, and this 118. That is missing from the tlinks no distances, okay? So let's see. I mean, you can already see, if we go to the top of this and search forward for items, you see items in the first output that corresponds to tlinks, but there's no items in the second output. So we ran dir on tlinks no distances, and we got no items. See that? Like, items would be down here somewhere. It'd be somewhere between here and here, and it's not. Okay? Why not? Well, let's do one last test. Okay? Let's just add one. You want to just add one? Maybe we'll just add one to it and see how that messes everything up. Okay, ready? Oh, I broke it because it's probably not consistent. It makes it not iterable. Okay, so let's put them back. Put them back. Oh, no, I did it. My syntax is wrong. Hang on, let's see if this does it. Yes, nothing about what I'm doing is happy or helpful. I guess I probably have to put them all back, but let's just do it manually. Oh, this is ridiculous. I know I'm going to do something. I'm going to make some mistake here, right? This is not the way to put data back. But we're just trying to prove. Oh, geez. Can I just prove a point? Now look at it. Okay. So we're going to reverse search for items. Look at that. Oh, geez. No. Oh, no. Oh, no. Damn it. Reverse search for items. It's in both now. Okay, so it's in the purple, which corresponds to our tlinks no distances, which we've just made into the same data as tlinks, and it has items as a what? An attribute? An attribute. Let's call it an attribute. I don't know. The vocabulary is still not my strong point on this stuff yet. Okay. What does that mean? Why do we care so much about that items experiment? Because of this. If links doesn't have attributes, i.e., if links doesn't have distances, okay, if you're dealing with something like tlinks no distances down there on line 137, instead of something like tlinks, which has distances on line 130, on 137, tlinks no distances is 138, line 138. You know, you've got to do something. What do you got to do? You have to as they say in their comments, make the distances 1 by default. That's what this whole thing is doing. This whole has attribute compound statement suite. Which part's the suite? Which part's the? I think the if is this is the header, and then this is the suite. But I don't know. I looked at it for a minute and I was like, it's just, I'm gonna say it wrong no matter what. I gotta get used to it. And it's just using like a for loop. So for link in links. So you make links is an iterable. It's a memory object or a data structure that you can iterate through. Like think of going line by line through something or item by item through something. So for each item in links that we're going to just call it a link, we want to set that link. We want to what? I mean, maybe the braces tell us that we're doing a dictionary here, and that the link part of it is so in the, if we're dealing with tlinks, no distances, then this A to Z, okay, is going to be the link. Oh man, no, that is what I want, and I don't want the blue. Is going to be that, okay, and then what this is saying, I think, is just to put a 1 next to the after the colon to make it into a dictionary with items. Okay. All that just to make it in, just to set the default distances to 1. But all of our Romania stuff has distances. Our links have distances, so it doesn't matter to us. But what does matter is understanding what the hell this code does. Okay. I didn't even after all that I got the dots. What should we write? So if your iterable, let's say if your, I can't call it link. Well, I guess links doesn't have items. What are the, I don't know what the items are called. Are they attributes? Let's say attributes. Attributes. Set items to 1. Set each items to 1. I guess is the best way I can say that. Okay. If not directed, we're not going to deal with this. Directed is not, we're just not dealing with directed, but you can see, directed graph search, but you can see in our arguments, our initialization of a map that directed is set equal to false by default. And the list function just creates a list of objects when given an argument. So if we're going to I guess we are talking about it. So for the vertex 1, vertex 2 tuple in the list version of links, so if you pass the links dictionary to the list function, you're going to get a list. And that just means like, a thing that is in square brackets. Then do this for each tuple in the list version of links. Set the reverse equal to itself. So like v1, if not directed. So ours is not directed. So I guess what they're saying, this does pertain to us because our map is not a directed map. I think it has to do with like going backwards. Like you can go backwards, so you can always go backwards. I don't know, but it's something like that. And basically, what this little attribute, what is it doing? It's setting. It's adding to the links dictionary here, I think. But wouldn't it need items? Or maybe this would include, so if we do this setting equal to, this would not only create a v1, v2 out of this, oh no, that was, okay, it's not that bad. Create a v1, v2 out of a v2, v1, but it would also include the thing after the colon. If you know what I mean, down here. So the V1 is A, V2 is Z. Is it also going to create an entry with the 75 there? It almost certainly would. Yeah, because like when you put these in brackets when you're dealing with a dictionary, it's a way of referring to the key, and the key is always paired with a value in a dictionary. So I'm going to say that this would take, in this line here, this suite, I'm going to call it a suite. If passed this argument down here, look at all this stuff. I got to look. This is not helping. This is not helping. If it were to be passed this key value, this key a comma z, this key tuple, it would create another entry in our links dictionary that would be the reverse with the same 75 distance value. So it would be a z comma a colon 75 entry in our links. I think that's what this line is doing. We won't know for sure until we can actually get a full problem up and running, but we're not there yet. Self.distances is links. Our links is a dictionary. So self.distances would just return the dictionary? I guess. Self.neighbors is the one that we intended to focus on today, but which finally gets to the thing that we said we were going to talk about. Multimap, the multimap function, which takes the links. So here it says pairs, okay, because it's a function, it's a general function. It's not specific to our class map, okay? But just replace that with the word links, because that's what's going to get passed in our instantiation of map. So we're going to pass our links dictionary to multimap, and it's going to produce a dictionary. Great. Well, it's not going to just produce. It's not just going to turn our links into a dictionary. There's no need for that. What it's going to do is do some stuff to it and then produce an output dictionary. So set the result equal to the default dictionary list. What the hell does that mean again? I don't know. And then for key and value in pairs, which is for us is links, okay? So for each key value, the result, default dictionary list. Default dictionary takes the argument of list. What's the list? What's the list? It's not anywhere else in the source except here. List has to have a, that's why I thought over here that it was like the list function, but that doesn't look like a list function, although maybe it is. It really, it's syntax highlighted, just like dict. So I think it is the list function. And actually, please just work. Oh, damn it. All right, it's okay. So over here, wait, did I just leave it open? Nope. Oh no, this is gonna not give me anything. Okay, I think I saw somewhere in some documentation something about lists, but that's okay. Everything's fine. We're gonna leave that one for now. Can we really leave that one for now? Damn it. All right. We want to return the result. The first thing we do with the result is we set it equal to the default dictionary list. See, we don't understand. Okay, let's just search this. Let's just see what we get. I'm doing point and click here because my hotkeys, my OBS hotkeys are broken down on me. Okay. Default dictionary Python, Geeks for Geeks. These guys are, okay, I'm not going to say nice things. Don't email me. All right, stop it. See, okay, I'm done with you. Screw you guys. I'm not doing this. Screw that, okay. How does collections.default dict work? Okay, I've read some examples. Yeah, this is what I use. No, I'm not gonna do this live because it's just gonna be me reading and it's gonna be boring. I gotta push on this. Like I can't. Maybe I can. Can we run an experiment? Okay. Do we have what we need? We have links. We have tlinks. Do we have multimap Let's run multimap on tlinks. Let's just see what happens. Print multimap tlinks. Just do it. And don't do these things. Comment region. See if it works. Default dictionary class list. It's done something. What the heck has it done? Default dictionary class list. Okay, so it's a list object. Okay, so that list is a data. It's an object. It's a class. And then we have a dictionary that has the state A, and then it has ZST. Ooh, look at that. This is interesting. It's creating. Oh, I know what it is. Oh, okay. This is so I wanted you to, I was going to emote, but then I had to click a button, and now the moment is gone. So let's go back. Okay, check it out. So what this has done, see, this is the way to do it. Just run the damn little function and just see what it does. This is a dictionary. It starts with a brace. I mean, it ends with a brace. That means it's a dictionary. The first key value pair in our dictionary is A as the key, and then the values are Z, S, and T. Does that sound familiar? I think it should by now. A, Arad, Z, S, T. Those are the neighbors. Okay? Let's continue. You might know where this is going. The second key value pair in our new dictionary is Z, which is the key, and then A. Z is the key, and it's a state, and A is its neighbor. Okay? So here's Z, and as far as our program knows, the only neighbor it has is A. Okay? Now, finally, S has a neighbor of A, and T has a neighbor of A as well. So what it's done is it's doing what we need done. If we give it the links, our simple dictionary of links, and we run multimap on links, what we get is the neighbor. It's just so stupid. Like, now that I run it, it's so stupidly obvious. But like, I always do this. I always think like, I'm not going to run stuff until I understand it. But then, like, running that is so freaking obvious. It's so much easier to understand what it does when I just, okay, shut up. We get it. But in case you don't, come on, there we go. Oh, come on, please, there we go. We need the neighbors. We need to set an attribute of our object, our map object. We need to set the attribute neighbors equal to something, and we had to build a function called multimaps that takes the argument of the links, okay, and links in our case are very simple test links, or in the case of Romania, it's this whole big map, big part of the state space, which is the actions, which is to go from O to Z and to go from O to S and all that stuff. Okay, but that's the links part of our input to our map. To our instantiation of map. It takes the links part, which here it calls pairs, because you can't always use the same names, it's confusing, but pairs, and it returns a dictionary. And the dictionary is, as we see down here, a dictionary of key value pairs that correspond to states and their neighbors. Okay, neighbors and actions are synonymous in this context. Okay, and the way it does is it starts it with a variable that it sets default dictionary equal to list. From collections import default dictionary. I still don't quite understand why it's done this way, but this below makes sense. So for the key value pair in links, it says pairs, but in ours it'll be links. For key value in links, you want to add to the result default dictionary list the key value pair. And then when you're done with doing that for each one of the key values, then you just return the result. Okay? And we just saw it done there. Can we increase our confidence in this interpretation? Of course we can. Let's update links to have yo and mama, and she is, let's say, 90 miles away. And we need to add one more just to prove to ourselves. We want, so these are actions. So you can go from yo to mama if you're willing to drive 90 miles. But what if you, what can you do once you get to mama? You can go to, let's say, mama dada, if you're willing to drive 91 miles. Now, no, go, there we go. Let's do it again. Look at that. Now we've got the neighbors of yo mama. We got yo mama's neighbors and yo dada. All right. I hope that, I hope that's clear. So we've got a dictionary here. Our dictionary output is our neighbors from our multimap function that fetches our neighbors when we give it our links. So you give it a dictionary of links, and it tells you the neighbors of each link. So those are the actions, the places you can go from each state in your state space. Yep. In your state, your state space has, oh, shut up. You know what I mean. Okay, so from A, you can go to ZST. From yo, you can go to mama. From mama, you can go to dada or back to yo. From Z, you can go to A. From S, you can go to A. And from T, you can go to A. And from dada, you can go to mama. That's what it did. It did exactly what we needed to do. These are the lines of code that do it. I gotta fiddle with result equals default dict, which takes a list. Can I? Oh. Okay. Let's do some funny business. Print. I mean, this is so obvious. When I do it, I just feel dumb for not doing it earlier. What is this? I don't know. Why don't you print it, dumbass? Okay. No. Let's do it again. And let's do also, just to keep things quiet. Oh, geez. Okay. What do we get? Look at that. 3 times. Oh, okay. Here's it's that probably makes sense. So first we printed the default dict list, and then nothing happened because we didn't give it an argument. And no. Why did that do that? I don't think it should have done that. I didn't use multimap for anything. Why would it? There should have been no output. So first of all, let's just confirm that we caused those 3. We did. Just putting that in once prints it 3 times. Why? Okay, let's just do it again. Yeah, it's just that one line 125 that's producing those 3 lines of default dict. What does that mean? What does any of it mean? Well, I thought this was going to help. Oh, I know. Let's, every time we go through the, I think we're just going to confuse ourselves for little gain here. Let's go through the, let's give it a proper argument. And let's make it easy for us to understand what's happening line by line before the for loop. And then we're going to say, I'm going to try and be slick here. I'm not a good programmer. So I equals 1, and we're going to say, ooh, I'm butchering this code. This we're going to have to totally. Okay, so man, this is not. I'm not going to do well at this. I know, but you got to go for it, right? Print I, and print, and then I equals I plus plus. So maybe this will give us some debugging information. No. Is it just I plus? Yeah, probably just I plus. Oh no, not getsta. Go. No. Oh, how do you do it? Oh, I forget the. I don't remember the syntax. Oh, I think it's just I plus plus. See, this. I knew this was going to happen. Python iterate. I just need to know the syntax. I know you can't see my screen. I don't want to like put other people's web pages and then they come after me. I equals. It's I plus plus. I did it right the first time. Damn it. Maybe I didn't have a space. Why is that not working? This is not cool. There, good. But why did it do 46? Okay, whatever. It should be. There's some way to just to iterate I without typing the 1, but I don't know. I don't know what it is. But why so many? Why are there 46? What is all this crap? What is all this crap? Before the for loop, 1, 2, 3, 4, 5, 7, 8, 9, 10. And then it's back to before the for loop. That is unexpected behavior. At least for me it is. Oh, we didn't give it, we didn't do anything. Why is it even doing anything? Because I didn't do this. I didn't uncomment this. Why the hell is it doing anything? Because, because I put print. So when it defines these, no, you shouldn't. I'm defining the function. I'm not calling the function. Who's calling the function? Multimap. Who calls? This was commented out. Multimap. Maybe it's because it's up there. Oh, okay, here we go. All right, let's just make sure we didn't. Okay, does a bunch of garbage. Is it because we're instantiating a map? Let's see. Let's just comment region. God darn it. What's all this? I don't even know what's in all this stuff. Here we go. That's okay. G. Yes, there's a map too. There's another map. I got to turn off all these maps. Okay. Hopefully this is followable. Now nothing happens. That's why. Okay, so I was instantiating these maps, tmap and tmap no, and Romania, and all this stuff was being printed to the screen, even though I didn't think I was doing anything. But that's because I'm just, I'm being a joker here. Now let's just do print multimap. Okay. Let's not do any of this other stuff. We're going to print multimap links. Sorry. And what we're trying to do, in case we've lost the thread here, is we want to, at this stage, so we're curious about this default dict list. So I want to print, and I give myself just a little English cue here before I print the actual data, print the default dict given the argument list here. And then, and since this is since we're going to do a for loop, let's set I equal to 1 outside of the for loop. And now, the function, the normal function, the one that they wrote, is going to for each key value in our links, it's going to append key and value to the default dict list, which is called results down here. And then I just want to print I when it does that. And then I just want to print the new list. And then I want to iterate I. That's what I'm doing there, okay? Let's see what happens. Okay, so let's see. So before the for loop, there's nothing in it. It's not until the end. Why is it not until the end? Why? because my thing is, my little debugging program is no good. Only the last print of default dict has data in the dictionary. And that's not even the good. Why? That dictionary looks truncated too, doesn't it? Tlinks has all this, but before we got a much bigger dictionary. Oh man, I've broken something. Okay, let's just oh, for Pete frickin' sake. This, I didn't want to comment out that anything anyway, thing anyway. So that I'm just commenting out everything, going back to what I think is normal to see if I can get that normal dictionary back. No. But we did, when we did, well, I can't really see what I did when I got that other dictionary, and this is a big pile of snot. Because I did it twice, because I had to do it twice. Where is it? There's the Yo Mama dictionary. That has AZST and all this stuff. Why is multimap different now? What have I done? What have I done? You know what I'm saying? Like, this is the default dict way up here. It's got all of the possible actions for all the states here, but here it's like we've only got 3 states. Why? I'll run it again, see if anything changes. Why would it? I haven't done anything. I didn't do anything to break it. Did I? Print multimap on tlinks. Tlinks has... I don't know what I did. I don't know what I did to break the dictionary. The default dictionary. Must have done something. It's not cool, man. What's in here? Nothing. All right, man. I'm going to have to push. I'm going to have to surrender on this. I don't know what I did, and I don't want to sit here and leave, blank audio space. Shit. I don't like this. This feels like defeat. I don't like to end on a defeat. I'm not going to end on a defeat. Look, if I've got you at 1 hour and 8 minutes, you're just hanging out, right? Like, you probably got a drink in your hand. Just keep going with it. Let's fold all the nonsense. Clear our... Oh, you know what else we'll do? We will do my new trick, which is no comment mode. Look at that. I don't even have to fold anything now. Although folding is sometimes better. Okay. Why does it do what it does? We didn't do anything to map. We're not even doing anything with map. Right? There's nothing... There's something folded there. Let's unfold that. It's all comments. Good. This is all comments too. All comments. Okay, that's kind of a pain in the ass. Print multimap on tlinks. That's what we're doing. Tlinks is this one. You can get from yo to mama and from mama to dada, and you can get from mama to yo and mama to dada, but it does not say that down here. Why? I'll tell you what I'll do. We'll go back to the source to see if I can quickly tell what I broke. Result equals default dict for key value in pairs. Result equals default dict for key value in pairs. Result key append val. Result key append val. Return result. What is it? I have no idea. I hate this. I'm going to go nuts. I am already nuts. What happens if I get rid of the Yo Mama? It disappears, of course. Yeah. But it doesn't show the others. It's some spacing thing. It's some spacing thing because it's not doing the loop. Okay, so let's get the comments back here. I've broken the loop somehow, right? What's the... Okay, here's what we're going to do. We're going to save our messy one. Okay, and comment region. Now let's get rid of these things and just see if it starts behaving itself. Because it really looks like it's not going through the loop. Okay, this is sort of like what it looked like before. First, let's just try that. AZST. Dude, I'm nuking this thing. I know the comments have nothing to do with it, but I still want them out because I need to be able to concentrate. Delete. Okay. Result equals default dict. Actually, you know what? I should just copy in the source again because I am dumbfounded and I am not happy about being dumbfounded. Okay. What's different? Doesn't matter. Let's see if their source code produces anything different. No. What did I do? Unexpected indent because I manually copied and pasted. Shouldn't have done that. Same. I did nothing. So why is my Yo Mama not my mama anymore? This is bullshit. That's the good one, right? I'm just going to paste it up here so that I can keep looking at it without going up the map, or up the history. What are we looking at? A is a state, Yo, Mama, Z, S, T, and Dada. And what did we do? The default dict class list. Default dict class list. This is debugging, folks. We are debugging. We're bugging and then debugging. It has nothing to do with this stuff up here, right? There's nothing... What is all this? Oh yeah, that's the... And this is... We're not using that. Oops, sorry. Multimap. I'm passing it tlinks. Tlinks has AZ, AS, AT, Yo, Mama, Mama, Dada. It's doing the default dict thing. And then for the key value in pairs, it's appending the key values to the results and returning the results. I'm passing it tlinks. Print multimap on tlinks. It's saying you can go. This is going to drive me crazy. I'm going to go crazy. We had it. There's some comma or something that I missed. But I didn't do anything with the commas. What about... see, I can't see what up here, I can't see what's in the file that generated this because my method is not good for this. All right, I'm gonna have to admit defeat here. This is not something I should continue to live stream to all of those many viewers I can see. All right. Well, shit. I'll figure it out. But I was hoping to not end on a defeat. Blast. Blast you, multimap. All references will be in the PDF notes and all that stuff. Same time tomorrow. I will figure it out by tomorrow. And I won't even go to sleep until this is done. This is so annoying to me. But, yeah. I'm not happy about this. This is not cool. But you understand. Everything is fine. Signing off.